In this video, I'd like to talk about the two different types of statistics that we see in this class: inferential statistics and descriptive statistics. Now, I'd like for you to add this outline to your notes or have them on a sheet of paper in a binder or in a folder that you can reference in class or while you're working on different homework assignments. So please make sure that you're not just watching and listening to this video, but also copying it down as well. Now, a statistics math course requires as much vocabulary practice as it does mathematical knowledge. So that's what we're working on right now is the vocabulary that goes along with the course. So what we're going to say, and what I'd like to share with you, is that descriptive statistics is the type of statistics that's used to organize and summarize information. So it's good for organizing and summarizing information. And this statement came from our textbook on page number 3, so you can access the electronic copy to see that if you need to. One example of descriptive statistics is used in the sport baseball. If you're at all familiar with that game, you know that statistics are used all the time. Some statistics that are frequently shown are players' batting average, or on-base percentage, among others. There are many different types of descriptive statistics found in baseball. Now, in addition to baseball, our parking lot activity was actually an example of descriptive statistics. And if you remember, in that parking lot activity, we made note of the style of vehicle, the color of the vehicle, and the manufacturer. And again, these two are examples of descriptive statistics because all that we did with that data is we looked at a bunch of examples and we organized and summarized examples that we came across or information from a population. And a couple of ways that we showed our descriptive statistics is that we constructed or we concluded our findings by creating graphs, charts, tables, and other calculations of averages, variations, and percentiles. We didn't actually do these calculations, but they are part of descriptive statistics. Some of the more popular results within descriptive statistics are the creation of graphs, charts, and tables. So again, descriptive statistics, it describes a population, what we saw, what we observed. Inferential statistics, on the other hand, allows us to draw reliable conclusions. We draw reliable conclusions based on a sample. If our population is too big, we take a sample of the population and try to reach a conclusion about the entire population by looking only at a small sample. So one example of inferential statistics would be political polling. And inferential statistics is also used by insurance companies. As far as political polling goes, if you think about it, if a candidate is running for office, they would go out and take sample polls of the population to see if they are getting their point across, if they think they're going to get the votes. And for insurance companies, they would only like to pay out insurance claims if they're not going to lose money overall. So while they ask for you to pay your premiums for car insurance or homeowners insurance or something like that, you pay a certain amount of premium costs in the event that you have an insurance claim to pay out. So they take into consideration your age, the type of vehicle that you drive, and they look at all of the data that's been collected to help decide what would be an appropriate rate to charge somebody so that they don't lose money insuring you. So inferential statistics is used by a lot of large companies. They frequently hire mathematicians to work statistics for them. But what's really important is that you properly identify your population and your sampling methods, because they are significant to inferential statistics. If you have somebody that incorrectly identifies a population or incorrectly produces a sample of that population, then the inferences, the inferential statistics that come from that data would be flawed and not usable. So sometimes there's more to a statistician's job than just simply doing the math. It's developing observational studies and experiments that go along with them. So tomorrow in class, I would like to start our discussion with these two questions. So start thinking about these here and have an answer prepared. Just jot down maybe a sentence or two and be prepared to share that with a group tomorrow. That's how we'll start our day. Question number one that I'd like to talk about is, why was our parking lot data more like an example of descriptive statistics? Why is that not inferential statistics? And if you think about it, we could take the data that we collected and use it in an inferential manner. So what sort of questions would we answer, or how could our data be used in a inferential statistics setting as well? How can we take that parking lot data and use it in a different fashion than what we did in class? So again, think about those tonight and be prepared to talk about them for the start of class tomorrow. Thanks for watching.